Hey, software developers and IT procurement pros. Welcome to this explainer where we're going to completely tear down the architecture of a really fascinating piece of software, UTPS PRO v9.0 Turbo. If you've ever dealt with medical tenders, you know all about the massive administrative bottleneck of tracking and validating medical devices. Well, this software is built specifically to crush that problem using sophisticated robotic process automation, or RPA. Today, we're popping the hood, we're going to analyze the tech stack and understand exactly how this system transforms a tedious manual workflow into a highly efficient automated developer pipeline. Let's dive right in. Here is our rapid-fire roadmap for this explainer. First, the need for automation in tenders. Second, system architecture and infrastructure. Third, automated querying with RPA. Fourth, reporting and data outputs. And fifth, security, performance, and cost. All right, Section 1, the need for automation in tenders. We need to start by setting the stage in the high-stakes environment of medical tenders, where speed and accuracy are literally make or break for hospitals and suppliers. The core problem developers are trying to solve here is human latency. The old-school method of manually querying the Ministry of Health's UTS platform is agonizingly slow, and it just begs for human error. Relying on human operators to collect data for hundreds of devices simply doesn't scale. So the solution is RPA. UTS PRO v9.0 Turbo completely swaps out that painful manual bottleneck with a professional robotic process automation solution. By doing this, it standardizes and drastically accelerates the data prep required by hospital tender commissions. It's a textbook case of using software to completely bypass human limits. Moving to Section 2, system architecture and infrastructure. Let's actually look at the back end that makes this automation hum. For the developers tuning in, this is the really good stuff. If you're evaluating this platform, here is the exact tech stack driving the software. It's built entirely around the modern JavaScript ecosystem. The backend is orchestrated with Node.js and Express, which gives us that incredibly fast, asynchronous foundation you absolutely need for heavy I/O web automation tasks. For the database layer, they went with SQL.js. Honestly, brilliant choice for a local deployment. It compiles a lightweight SQLite database right to WebAssembly, meaning it runs perfectly in memory without forcing hospital IT staff to spin up complex external servers. Finally, for reporting, the system leverages Excel.js and PDFlib. But the real star of the show, that's the automation framework. The heavy lifter in this stack is Puppeteer Extra. This is a modular plugin framework built right on top of standard Puppeteer. In this context, it serves as the automated muscle, the core RPA engine, spinning up headless browsers to programmatically navigate and extract data straight from the UTS platform. What's super clever here is that by using the extra version, the system can leverage stealth plugins to flawlessly mimic human interactions. It handles dynamic web elements and complex queries that would instantly trip up a basic script and get it flagged as a bot. It just acts as a tireless, high-speed virtual operator. Section 3, automated querying with RPA. Let's map out how this automation actually flows end-to-end as a functional developer pipeline. Check out this step-by-step data flow. It kicks off at step 1 with an AI barcode extractor, an intelligent layer designed to parse out barcodes from messy, unstructured initial data. Once extracted, we jump to step 2, feeding those barcodes straight into the Puppeteer engine for real-time querying against the UTS database. Step 3, that fresh metadata is instantly structured and stored locally in SQL.js. Finally, step 4 pushes it all out to the document generators. As a developer, you really have to appreciate the clean modularity here. Extraction, querying, storage, and output are all handled in highly efficient, distinct phases. That brings us to Section 4, reporting and data outputs. Because, let's be real, scraping data is totally useless if it isn't formatted correctly for the end user. Notice how specific open-source libraries are perfectly mapped to the strict reporting needs of tender teams. Tender commissions need very specific formats, so using Excel.js, the system delivers advanced Excel reporting. We aren't just talking about a messy CSV dump. It formats cells, adjusts layouts, and creates ready-to-submit spreadsheets natively. Paired with that, PDFlib handles archiving and merging. It takes all those various certificates pulled from UTS and automatically merges them into a single, cohesive PDF archive with zero external dependencies. It perfectly bridges the gap between raw web scrape data and professional, compliance-ready documentation. Finally, Section 5, security, performance, and cost. Let's ground all this tech in some hard performance metrics and commercial realities. 3 minutes. That number is the ultimate validation of this entire Node.js and Puppeteer architecture. It takes about 3 minutes to process 100 barcodes.
Imagine the manual equivalent of that. Typing 113-digit numbers, waiting for pages to load, downloading PDFs, copy-pasting data. What would literally take a human hours of mind-numbing work is knocked out by this RPA pipeline in just 180 seconds. It is a massive technical leap.
And while speed is great, accuracy is non-negotiable. The system hits a 99.9% data accuracy rate. Because the data is scraped directly from the source via Puppeteer and parsed directly into SQL.js, without human intervention, the risk of typos or copy-paste fails is virtually gone. That kind of precision gives major technical assurance to IT procurement pros relying on this data for their bids. To protect this powerful engine, the developers implemented an HWID or hardware ID lock. This means the software license is cryptographically tied to the physical hardware it's installed on. For IT admins managing enterprise deployments, an HWID lock is an incredibly robust way to manage professional plans and ensure the RPA tool isn't being distributed or misused across unapproved networks. Commercially speaking, the licensing is broken down into two very straightforward tiers. You have the luxury plan at 700 Turkish lira and the maximum plan at 1,000 Turkish lira. When you factor in the highly optimized node backend, the AI extraction, and the massive amount of human hours saved, the return on investment here for a medical supplier is incredibly aggressive. If you're an IT manager or a developer looking to integrate this kind of architecture into your own procurement workflow, you can reach out directly to the official contact provided. As we wrap up this explainer, I challenge you to take a hard look at your current data collection pipelines. Considering the sheer time saved and the 99.9% accuracy guaranteed by this Node.js and Puppeteer stack, how might integrating a dedicated RPA solution like UTS PRO completely redefine the speed and competitiveness of your next hospital tender bid?